please come forward, because that's going to be helpful for the ones who are coming later. So yes, once again, welcoming you all to the day 3 of the Cypher 2016, brought to you all by Analytics India magazine. Quickly starting off with the day 3 session here at the Hall Arabica. So the topic for the first speaker is transforming an organization in the Indian market from data curious to data driven. And for this gentleman, I have a person who's data scientist by day, Vanitha de Silva. Of course, that's the person who's driven by identifying patterns, deriving insights, and problem solving. She has been instrumental in Oxigen's evolution to a data-driven organization. She and her team enable key business decisions through the actionable solutions they develop. When they're not working, they are exchanging random trivia or the Game of Thrones analyzing, usually over chai and peanuts. Ladies and gentlemen, she is the head of data science at Oxigen. Please put your hands together for Vanitha de Silva.
Hi, morning everybody. Firstly, thank you for braving the traffic and making it here on a Saturday morning. So just a little bit about Oxigen before we start. And Oxigen is a major player, a solution provider in micropayments services, and we aim at providing these services real time. And data science at Oxigen focuses on developing solutions to meet this requirement of the business. So we're a small team, we're a lean team, we're pretty passionate about what we do. And we're looking to tackle real problems using data. So one of the first questions that really arises, why do you need data science? Or it's kind of established that okay, you need to have analytics, you need to have data science, and with some regard in your organization. But what is really the pressing objective behind building such a program? Is it just the fear of missing out? Everyone's doing it, so it's something magical out there, and it's going to make everything better, push your costs down, get your revenues up. So is that the reason motivating your organization to build such a program? Is it that they have noticed that the data is inaccurate, it's not really a good measurement tool, it's not helping them take the right decisions? Or is it that your systems can no longer keep up with the pace at which your organization is growing? So this was the situation for Oxigen. We are about 12 years old. We've scaled rapidly. We've grown pretty quickly. And our chairman, Pramod Saxena, who's, as most good leaders are, is a visionary leader, said, hey, you know what? I want to monetize my data. I want to unlock the potential it has, but my systems can't keep up with it. I'm not getting the data on time. I'm not able to take decisions. And when I do get the data, it doesn't mean much. So what he wanted to do was kind of bring a mandate that in God we trust, all others must bring data. We need to, strategy has to be measured scientifically. It has to be developed, with, the results have to be able to be measured. And that is what brought about the need for big data and the data science. How exactly do you need it? When it's a small organization or when you're starting up, I think your focus is more on the infrastructure, because you can still get real-time data with just your SQL warehouses, your traditional setups. But once your startup goes into hypergrowth, or in our case, if you have a huge organization with legacy systems, your operational inefficiencies creep up. You're not going to be able to get the... Sorry? Yes, that's the... Right, exactly. So like, for instance, that's, a lot of the time, that's the kind of insights you would kind of get, which are inaccurate. And that's when you need to get your systems upgraded so that data science can then do its job. So that's precisely what we did. We looked at the current processes. We got aligned with the business leaders, the decision makers, looked at all the available data sources, mapped it with the tools and platforms, and decided we need an overhauling of the entire system. And once we did that, then we were able to build our solutions, develop analysis, and really start changing the business. So instead of really talking about a specific problem or the solution, I thought we would talk a little bit more about the journey that we went through and the learnings from the journey, really. So the first thing that we learned was that, especially in the Indian market, you need to prioritize the transformation. So one of the things that we learned very early on in life is that you don't get everything that you want. So there's the golden triangle where you can keep your costs down, but your time to action kind of increases if you want your quality product. So if you're looking at cheap, good, and fast, you're only going to get 2 out of 3 at max. You're never going to get all 3. So the best way to achieve your goal then is to really, really understand the pressing need, which way your business is aligning, where it's headed, what is the investment required, figure out the best use cases, and then start plan your way forward using that. Second, cannot stress on this more, get the infrastructure right. Unfortunately, we have too many choices out there. All of them work, some of them are for specific use cases. Some of them work better with other softwares or tools. So you really need to understand what your use case is, how much investment your company is willing to make, the compliance, the security, all the regulations you're governed by. And that's when you can figure out where you're going to put your data and what tools are you going to use to mine and massage your data. So whether it's going on cloud. So cloud is great. Cloud was supposed to be the answer to all of these. But if you're not careful, your costs can go right through the roof. So, and then if you go back to on-prem, then can you really achieve that efficiency of scale? Popular choice of especially large organizations these days is to kind of go with a hybrid setup where that data remains, so they're not involved in that whole movement of data, but they're processing and scaling up their solutions on the cloud. So once you got your infrastructure right, the next thing, the most difficult thing is to build a data culture. So unfortunately, the way data is perceived in the organization will really play a great role in how much data science can really do. And data is usually perceived in a clinical way with, as hard, cold facts, and which kind of results in it being used more as a measurement tool. So you might get more formal requests for statistics. What is the result of my campaign? How many customers do I have? How much are they? And that kind of really affects the potential of data science, because unless you are proactive, unless you are working directly, towards the growth and the future of the company, you're not really going to unlock the true potential of your data. And so that really comes from creating a culture of data. It really helps if when you start on top and you have the buy-in of the decision makers, the leaders of the organization, so that it can trickle down. But still, when it comes to an organization that has been around for a while, and people are used to doing things in a certain way, they're not so willing to change. So one of the things we found was the best way to do that was to really, really partner with the teams and work cohesively with them. So nobody really likes to be told, this is how you should ideally do your job. So whereas if you say, hey, you know what, I can help you do your job better, it's just going to help you achieve your goals so much faster. One of the things we found that really helped was to kind of educate the organization, have just huddles and knowledge sharing sessions around on various things, on tools, on just brainstorming, problem solving, how to use the solutions, what is the data in the organization, what does it contain, what are the kind of metrics you can get out of it. And this really helped people to understand what they can do with the data, or that there is something which can help them get their job done so much faster. Another way is especially, so when it's a small organization, you can, it's easy to work across teams and talk to everybody and keep everyone in the know-how. But when your organization grows, you're sitting in different locations, it's not so easy. So democratizing the data, again, really, really helps. And by that, I mean provide tools or a platform for people who don't really know how to use it or code or program to be able to pull the data themselves. And this helps your data scientists also. It frees up their time from the mundane tasks of gathering day-to-day statistics, which is also required for the organization, and focus on the larger, long-term, more complex problems which they can help out with. Finally, there's a lot of debate about whether a centralized data science team versus an embedded data science team. And I think the one thing that really worked with Oxigen was we went for a hybrid of the two, wherein our data science team sits in one location together. So we really learn off each other, and we work cohesively, and we can build, solve larger problems together. And we're at a vantage point where we can, we're sort of like a neural core, I could say, of the organization, and we have a vantage point where we can look into all what's happening across teams. But at the same time, we partner with each of these teams so that we're involved in their day-to-day activities, and we can take a more proactive approach. Finally, you have the data science a data culture in your organization. You have the infrastructure. You're building solutions. One of the biggest challenges is just to tame the data, right? So information is beautiful, but data is very, very, very ugly. It can be incomplete. It can be dirty. It can just not make any sense. And when it comes to the Indian market, you have huge volumes of data generated in a short amount of time. And you're looking, even if you forget about the data in your system, if you go up to your third-party sources, if you look at your census data or any extra information, it's going to be a nightmare. Data scientists typically spend 80% of their time just in data munging and cleaning the data, massaging it to a form where it can then be leveraged for insights. We wanted to reverse that. We wanted to kind of spend only 20% of the time. So what we did was we built an enrichment layer on our platform, and it's where we cleaned up the data. We put in a lot of effort into that. We also, in the Indian market, you have incomplete data, happens a lot of the time. And at times, you still need the data, even if it's 80% incomplete. So we developed a lot of indices which help the various business teams, especially the operational teams, directionally make decisions at least, so to figure out where the demand is, where they need more coverage, problem areas they need to support, and this really helped them to meet their targets. So it's never about how big your data is, it's about how clean your data is, because it's only the clean data that you can use. So it really, really is beneficial if you can make that investment in terms of time and effort to kind of create that enrichment layer. So once you started developing your solutions and your analysis, it's very, very hard to create a data culture if it's not used and it's not implemented. A lot of the times what happens is because of the amount of work that goes into building a model or a solution or deriving insights, the last 10%, which is the communication of the results, is something that we data scientists don't really want to do. We just kind of want to move over to the next problem. And unfortunately, unless we implement those solutions or those results, it's of no use. So you can sit in a meeting with all the decision makers, and they'll be like, OK, great analysis. Yes, this is exactly what we want. And then they walk out of the room, and they forget all about it. And over time, then, what happens is that the data science will not be an integral part of the organization. And so the extra mile is to really, really just figure out ways of communicating your results in a way that the business users or people who don't even understand data can use it. So visualizations really, really help over there. Tools or data products, which they can kind of filter out or hover, mouse over to kind of get the insights that they want. Frameworks really help. That's one thing we found, kind of giving them an implementation plan and saying, this is how we think you should go ahead, coming to a decision right then and there in the meeting, and then so the next steps are to execute the plan. So really just stitching the entire story together with visualization, with insights, having that layer on top of your model, that really helps to see your results in action. And it is the most rewarding thing to see a model that you've built actually implemented in real life. Finally, as data scientists, we work in an agile manner, iterative manner where, okay, if it didn't really, your pilot wasn't really great, you kind of go back and you iterate. This doesn't work in business. The other thing we do is, we tend to do rather is like, hey, it's going to take 3 months to make the model. The first 3 weeks, I would have got to, say, 75% accuracy. And then I would kind of take another 1.5 months to improve that accuracy by, say, 10%. The business cannot wait. So the kind of mandates we got when we set up the data science program was, we want this program up and running yesterday. I mean, no exaggeration here. And that's the thing. The business cannot wait, right? In 3 months, your entire business might have changed. So this is the mantra we work by. I think this is all over the walls of Facebook. It's all over the walls in our office as well. Done is better than perfect. So we work in phased ways so that there's something for the business to kind of work and act on in a short span of time, while we develop the more involved and complete solution, which can then be implemented later on. So that's a little bit about our journey. And our office is on MG Road. Please drop in anytime. We'd always be happy to kind of hear your thoughts and help you guys out in similar challenges you're facing. I think we've come a long way. We've reached a place where our platform is stable. We are bringing in, introducing efficiencies, more and more efficiencies. We've implemented solutions, and we've seen, great impact. We're ready to take on bigger and badder challenges and more real-time problems. So I think we're just scratching the surface here. We have a long way to go. But so thank you. Any questions?
I actually want to hear when you said data scientists spend more than 80% of the time on cleaning the data rather than modeling or basically doing data science work.
Yeah.
And then you said that you guys actually built a layer on top of the data, I believe. Can you actually elaborate more on that and how it actually helped you guys?
Right. So have a big data platform, which is a Horton Workspace platform. We're very pro open source, apart from other reasons. And so our data resides in a data lake, and we extract it using Hive, usually most of the time. And one of the things we find is that the larger your data, the more it's going to take that much longer. And when you're on the cloud, you get charged by compute. So you really need to bring in efficiencies in the way you're extracting the data. And that really, that helps in deriving metrics, cleaning up the data beforehand, before you dump it into the data lake itself. So partitioning the data, so these are the kind of like the ways you really achieve that. It comes over time. It's usually iterative. And so it's kind of, every time you do an analysis, you figure out, hey, you know what, this is not the ideal way it is, and then you spend some amount of time refining the data. And whenever we do that, we kind of write scripts so that moving forward, when the data comes in, it's cleaned automatically.
I agree with you about the scripts. Just a quick question. So basically, when you write the scripts, you assume that the data source or the data that's coming from the source is in like a format that you guys know and that you guys actually can write a script on.
Yeah.
So what if it is actually different? Because as you said, the data is basically a huge jumble.
Right.
What if it's actually different than, say, the data that you got previously? Then I do not believe the script would actually work on the new.
Yeah, and so you need to have checks beforehand, right? So if it's away from what you expect, you need to have checks which would raise alarms and warning signs that your scripts are going to fail. That's what's going to help you out then.
Thank you.
We're a financial services company. Different ways. So in case of it being extremely inaccurate, so say 30%, only 30% is accurate, we look and see if we can use it directionally. So that's the worst possible case. If it's not, if your accuracy is a little higher, then you can go in for a few different methods using statistics and statistical methods and ways. Yeah, and then if you still need the data and it's not something you can directionally use, then you have more complex algorithms. You can go into Bayesian algorithms and stuff, which would help you use it anyway.
How often you face this issue like incorrect data?
So it's a great question. When we started off, so on day one in Oxigen, my boss told me, the data is all wrong, okay? And as a data person, I was like, hey, that goes against my very core. It can't be wrong. You must be reading it wrong, right? So it really comes to it really depends on the extent. Is it being captured properly? If you have two different data sources, 9 out of 10 times, the numbers will never map. So it really depends where the event is being created, Is it being defined properly, right? So for instance, a new customer can be at the point of a sign up or at the point of he's made a first transaction. So it really depends how it's being captured in the system as well. If there are derived data, how is it derived? So all of those things kind of come in. Inaccuracies, missing, junk data, that's a whole different ballgame. So then you need to kind of, deploy cleaning, text, mining if required, or statistical procedures. Mm-hmm.
To understand business, how long it will take to understand data, and build a model like if you can't wait for 3 months,
Yeah.
you just can't wait for
Yeah.
I mean, within a 15 days, can you understand the whole setup of business and build a model?
Great question. Easy answer is no, I don't think so. But no, I think it really is, it goes a little deeper than that. So if you're talking about a services kind of setup where you're coming in and building a model for an organization, usually you would define the scope of what you would do, and you would have some kind of sample data even before you get into the project, right? Which would help you to identify or understand what the complexities could be. So in 15 days is good enough to understand how much, how difficult the problem is going to be and what you can do. Building a model, it really depends on what you're talking about. You can build a model in 3 days even, right? If with the right tools, it's just an equation. If you have all the data and you're just about porting it, getting it, validating. So you can do it in 2 days, but 80% of building that model is actually preparing the variables. So when in a services kind of setup, I think it's a debate. It's really a debate over there. The knowledge that they bring in, because they have probably worked for a similar solution across different organizations, that can help them speed up the process. When you're doing it in-house, you know your data, and you know it really well, and you know the business, and you know exactly what it means. So your data exploratory, your data understanding, that time is